and we have a key idea of square roots, which has a special name, principal square root. If you type in a square root on your calculator, right? If I do the square root of 9, it always comes out as positive. The square root of any number is always positive. Okay? Where things get a little bit interesting is if you had started a question like this and said something squared is 9. What you've done so far is you did the opposite of squaring. What's the opposite of squaring? Square rooting. So most of you would square root both sides and write this, which is a little bit of a mistake.
Which page is it?
We are on the bottom of page 87. Because if you did just this, you would only get 3 as an answer. But there's another number that times by itself is also 9. What other number? A negative 3, right?
Yeah.
So mathematically, you may have seen this before, but if you haven't, I'll reviewing it right now, that if you square root both sides, you've learned that you have to add or subtract because the square root of 9 is only the positive 3. And this becomes actually important when we do, I'm going to show, it's kind of interesting because I can show you a new way of doing that same question. I'm going to say stick with the plus or minus, but technically this is what's happening, okay? So principal square root is always positive, but it says here, consider a square with an area of x squared. Does it make sense that the side length is the square root of x? And we have something new here that we could write the square root of x is always positive. So even if x was a negative number, you have to make this positive in the end. And so I could have solved this question this way, by showing the square root on both sides, and then instead of doing the plus or minus, done this. How many numbers have a distance away from 0 of 3? 3 and negative 3. But as mathematicians, we don't ever do this. We always do that plus or minus instead. But the key idea is when you take the square root of any number, it's positive. And the number one mistake that's made is that sometimes people just cancel out the square root and the square. Because sometimes it works. What is the square root of 5 squared? 5. And because square rooting and squares are opposite of each other, it sort of makes sense that they cancel out. But a mistake that's made is, what is the square root of negative 3 squared? Some students just cancel it out and say negative 3. That would be wrong, because square roots are always positive numbers. So order of operations, you would technically do what's inside first. Negative 3 times negative 3 is 9. And then the square root of 9 is always positive. The answer to this is 3. So an intermediate step is using the absolute value bars. If I know my answer has to be positive, and I want my square root and square to cancel out, I can make this negative 3 inside absolute values and then change it to positive. Because sometimes the math might not be pretty. Okay? Because technically, order of operations say you should do this first and then get to 3. Okay? But I'll give you one where you're not going to want to do the order of operations first. Anybody know the 31 times table? 31 squared? 961? No, not happening? Okay. So that's a problem, right? We don't know 31 squared. We can't do this intermediate step and then go to the actual answer, which is going to be 31. So instead, we just say, well, I know it's going to be the absolute value of this. And then I don't have to do that intermediate step. And that's what we're getting to in our next question, in example 2. Maybe I don't want to do all the intermediate steps. I know that square rooting and squareds cancel each other out, and I know the answer needs to be positive, so I can get rid of the square and the square root, but then I have to put absolute values because square roots will always be positive in the end. And 7 minus 10 is equal to -3. So this answer is going to be 3 in the end. So you can circle questions 6, 10, and 11. And again, we'll do 2 examples and then I'll give you some time to work on this.